Hello, Math 8 students. This is our next calculator exploration. We're going to be talking about angle sums and polygons. Before we start into our calculators, I want to get started on remembering what the angles all add up to be in the two figures that we know. In a triangle, we've talked about this so many times. We've proved it multiple times. What do the angles in a triangle add up to be? Thank you, Cole. 180 degrees. What do the angles in a quadrilateral add up to be? That's what we did in our last official lesson, not our last exploration, but our last lesson. Xander, 360 degrees. And so what we're going to be doing today, these are the ones that we already know. Let's extend that and see if we can figure out if there's a pattern and figure out how many there are in a pentagon and a hexagon. So to get started in our calculator, we are going to start with a geometry page. So everyone is now adding a geometry page. And what we're going to be adding to this geometry page, again, we already know triangle, we already know quadrilateral, so we're going to be adding a pentagon. Watch how we do this. Menu, shapes, we're adding a polygon. Just make sure it's a 5-sided polygon. So I'm going to go ahead and add these 5 points. 1, 2, 3, 4, 5. Don't forget to finish it off by clicking on that final point one last time so it knows that we're done building our 5-sided polygon. Going to give you some words of advice. The calculator is always going to measure the smaller angle. And so what that means, you do need to build your polygon in kind of a specific way. It needs to be a convex polygon, meaning every one of these points is kind of poking out. Here is a non-example. That's a concave. Do you see how it kind of creates a cave? That's where that word comes from. It's a concave polygon. And although it still works, it doesn't work in our calculator without doing a lot of extra work. Because it would want to measure this angle here, which is on the outside, instead of measuring the angle that's the bigger one that's on the inside. So just to make things easy for us, pull that out, make sure that it is a convex 5-sided figure. Just looking at everybody's screen, it looks like we still have a few students who need to finish that up. So please stand up if you have this done. That way you can help those who are sitting make sure that they have a convex 5-sided figure. All right, now our next step, I think we're not surprised by this, but we are going to measure the angles. Before we even get started though, I'm going to push all of these labels to the outside. It just makes things easier. I'm just going to move all of those labels to the outside. That way when I measure the angles, the angle measures can go on the inside. So take a second now just to make life a little bit easier for you. And we know how to measure angles, right? We've done that so many times. Menu, measure, angle. Let's get a measurement for every one of those. And this one will take a little bit longer. Once you're done, stand up. We'll get there. Right now we're just going to be measuring them. And most students shouldn't have any trouble with this, but do check in and see if someone who is sitting needs help or if they just need the time. So stand up again once you have this done. Now that we have all of our angles measured, now you guys also probably know what's going to happen next because we've done this before. We need to add them all up together. So menu, actions, text. This time we have to type in A plus B plus C plus D plus E because we've got 5 different angles to add. And now that we've got our expression created, you know the next step as well is probably going to be to actually calculate it. Now, can I have your attention on the screen again for another second? I do have some students who don't automatically have theirs labeled. So you might be like, I don't know which one's A, I don't know which one's B. That's fine, you just need to tell it. Pick one that's A, and then move to the next one and pick it to be B, and then move to the next one and pick it to be C, and so on. Since I do have mine labeled, I'm going to go menu, actions, calculate. I want it to calculate this expression. What's A? I'm going to call this one A because it's labeled A. What's a B? I'm going to call this one B because it's labeled B. What's C? Gonna call this one C. What's D? Clicking on what's D. What's E? Clicking on that one. And then it tells me what they all add up to be. I'm going to go ahead and place that down there. Stand up again once you have that completed. Check in with those who need help. See who's still sitting. See if they need that help. Okay, we got everyone standing, and now we can see that when I add up all of these angles, they all add up to 540. And even if I go through and not that, sorry. I want that to go away. There we go. If I move a point, it recalculates the angles, but notice the sum isn't changing because they're always going to add to 540. There is an exception. Watch. I kind of warned you about this already. Remember that convex, concave thing? If I pull it in, it's not adding up correctly. Why? Because it's measuring the smaller outside angle when it should be measuring the bigger inside angle. Okay, and there's a way to fix that, but it's a lot of programming in the calculator, and I don't have the patience to do that. So we're just going to make sure that we're keeping it convex. And you can see that no matter what angles I'm changing it to, it still is always adding up to 540 degrees. So let's return to this. What does that mean for all pentagons? What are they all going to add up to be? 540 degrees. Let's talk about why. Why are they going to add up to 540 degrees? Think about what we did in our activity the other day, where we saw that the quadrilateral adds to 360 because we can take a look at the thing. Hold on. There we go. We can take a look at the diagonal and see that the diagonal is cutting this into 1, 2 triangles, and a triangle with 180 and another triangle with 180 will add up to 360. And we can see the same type of thing here. In a pentagon, there's one triangle, there's a second and a third triangle. So that's going to be 180 here, plus 180 here, plus 180 here, for a total of 540 degrees. So put your heads together. What about the hexagon? How many angles in a hexagon? Quick 30-second discussion. Online students, that's quick 30 seconds of think time. What do you think? Ready, set, go. Okay, your time is up. How many the angles in a hexagon will add up to? Parker. They will add up to 720. And again, let's think about why they're going to add up to 720. We have 180 here, plus another 180 here for this triangle, plus another 180 here, plus another 180 degrees. Which is how I get to that 720 degrees. So what am I adding every single time I add another side or another vertex to that polygon? Garrett? We're adding another 180. You got it. That is it for today's calculator exploration. Angles in a polygon. There is that pattern. We can always just add 180 for every extra side or vertex of that polygon we have. We'll see you next time.